Yesterday we talked about finding the domain and range of a discrete function. A discrete function is when we have just dots or on a graph. So for example, we had a graph, looks like this. There were some points everywhere. And then we just had to find which x values or what numbers those dots were touching on the x-axis. And then we had to also find the y values for the range, which were the ones where the dots were touching the y-axis. Today we're going to talk about continuous graphs. A continuous graph is when you have a line or a line segment or a curve. They're continuous because, as we discussed before, they have millions and millions of different points. So even though you just see the numbers on the graph, there are more and more numbers if we were to zoom in super close that it could be. All right. Just because we see that a line goes from +2 to +4, there's all those different little points in between, like 2.1 and 2.2 and 2.3 and 3.9 and 3.99 and 3.999. And we can keep going on like this forever and ever. So instead of having to write down every single one of those possible answers, which would take us forever and we could never finish, we show how to do the domain and range of continuous graphs differently than we did the discrete graphs. So first, just some basics about continuous graphs. We're going to talk about the domain first. Of course, domain is dealing with the x values. So that's going to go from the left to the right because that's the way the x-axis goes. It starts on the left and it goes all the way to the right. On these graphs, sometimes we'll have a graph like this that has two endpoints, right? Whatever the furthest left number or the smallest value for x and the biggest x value or the largest number, those are going to be the two numbers that make up our domain for that problem. So you can see it has two borders because we have two endpoints. And then I'm going to put the smallest number here and the biggest number here. And this is telling me that any number in between the smallest number and biggest number is a possible answer. So any tiniest, littlest decimal or any fraction that would fit in between those two values is part of the domain. Next, we have situations where we just have one border. So we only have one endpoint and then we have an arrow. The endpoint tells us basically what our starting or ending point is. So this could be the biggest or the smallest number. The arrow tells us that we go on forever and ever and ever. So whenever we have a situation like that, we're going to say that x is going to be greater than or less than whatever number it is, depending on which way the arrow goes. If the arrow goes to the left, then all the numbers are going to be smaller than this one. So it would be less than whatever this number is. If this arrow is going to the right, like this, then we're going to have a greater than symbol because all the numbers for x are going to be bigger than that point. There are situations where we don't have a border at all, where you have an arrow going in both directions. Anytime that happens, that means that it is all real numbers for your domain. That means we could put any number that we could think of in for x and the problem will work because really this line goes on and on and on forever and ever, and this line goes on and on and on forever and ever. And then there are vertical lines that again go on forever and ever. And our x value for these vertical lines are just whatever number it's touching on the x-axis. Much like we talked about before when we discussed vertical lines and how they have an undefined slope. So that's a domain. We have range. So range is talking about the y values. We go from the bottom to the top when talking about range. We start at the bottom because we want the smallest y number, because looking at our X and Y axis again, this is the Y axis, so we're going to start at the bottom and go to the highest number, and all those numbers in between the bottom and the top are going to give us our range, or could be values in the range for that particular situation. So let's look at where we have two borders, or we have two endpoints on a graph. So as you can see here, we have, just like when we were doing the domain, we have two endpoints. The lowest one, or the smallest Y number, is going to be the bottom. The highest one, or the biggest Y number, is going to be the largest. And all of our Y numbers are going to fall in between there. So again, it could be any tiniest, smallest decimal, or whatever fraction you can think of that falls between these 2 points will be in the range. And instead of having an X this time, since we're talking about the range, now our answer will have Y. So the smallest number and the biggest number, all of our range values are in between those two numbers. Whenever we just have one endpoint and an arrow, again, we're going to use greater than or less than. If it's going up, like this line is, then it would be greater than, because all of the numbers will be bigger than this bottom one. If we have a line that's going down, like that, then it would be less than, because all of our numbers would be smaller than this number. Just like with the domain, whenever we have no border, or we have arrows going in both directions, then our range is going to be all real numbers. Because this is going to go on forever and ever, and this is going to go on forever and ever, so any number on the y-axis we would eventually find on this line. And finally, whenever we have a horizontal line, it's just going to be whatever the y-intercept is, because every single one of these values is the exact same for y. So whatever our y-intercept number is going to be the only number in our range. So now that we've talked about the basics, let's go over a couple of examples of how we can find domain and range in a continuous graph. Let's look at a couple of examples of how to find the domain and the range of continuous graphs. First, we're going to talk about a graph that has two different endpoints. So there's no arrows in the graph, meaning that it doesn't go on forever and ever in one certain direction. So to find the domain, we're focusing here on the x-axis. We want to find the point that is furthest to the left and furthest to the right of the graph. So I can take a sticky note or a note card or really anything that has a straight edge on it, and we can see that coming from the left, if I keep going and going and going, that this is the furthest point to the left of the graph. You can see that it's touching right here. The reason I want to use something straight is because it allows me to see what number it touches on the x-axis. You could even just draw a straight line and it would do the same thing. So here, this is the furthest point. This is my smallest x number where x is 0. So when I'm writing my domain, I'm going to write 0 for my smallest number. And then I'm going to take another sticky note or note card or anything else that has a straight line and come from the right and see which point is furthest to the right. And here I can see that this is the point. That's where my sticky note is touching the furthest right point of the graph. I come down and look, and that is x. That is where x is 4. So the biggest x number I'm going to have on this graph is positive 4. And now once I know my smallest and my largest number, all I have to do is fill in the middle, talking about the domain, so that we're talking about the x values. And then all of the x values will be bigger than 0, but smaller than 4. So that's how I represent that, just like we talked about on our notes. Now let's do the range. So the range, we're talking about the y-axis. So we want to go from the bottom to the top. So looking at this graph, starting up here at the bottom, moving my way up, and this is the lowest point for the graph. You're not just necessarily looking at where the points start and end, you're looking at the whole graph and the furthest that it goes down. So this is the lowest part of the graph, and this, again using the straight line, tells me that my y number is -1. So my smallest y number, the smallest possible range value I could have would be -1. Take something else, another straight edge. Starting from the top, I'm going to keep going down until I reach the top of the graph, which is right here. You can see both points happen to be are at the top of the graph. I look over at my y number and it's +4. You can see I even have a y-intercept here at +4. So I'm going to write +4. Since we're talking about the range, the y goes in the middle. And again, I'm going to use the less than symbols because -1 is going to be less than y, and y is going to be less than 4. This is telling me that all of my range, all of my answers are going to be in between -1 and +4. Now let's look at a graph with an arrow. Here we have a starting point and a line with an arrow that keeps going on forever and ever and ever and ever in this direction. So again, with my domain, I'm going to start at the left, keep moving my paper until I reach the leftmost point of the graph, put it down there, and you can see that this leftmost point touches where x is -3. So I'm going to write -3 for my smallest x number. Now I'm going to take one and see if I have a border or a biggest x number. And I come up here and this is the first time it touches the graph. But with that arrow right there, that means that the graph's going to keep going on forever. So really my paper would keep getting pushed more and more and more to the right forever and ever and ever. That means that there is no biggest x number in this particular graph. Since there's not a biggest x number, I'm just going to use the -3, my x in the middle. I'm not going to write anything for the biggest number. So my domain is -3 is less than x, or, and this is how you'll see it on a test or something, they'll flip these things around. They'll say x is greater than -3, because all of my x numbers, -2, -1, 0, 1, 2, 3, 4, 5, are all bigger than -3. So any number that is bigger than -3 could be in the domain of this particular function. Now let's try the range. So coming up from the bottom, you can see that there is no lowest point because of the arrow right here. That means it's going to keep pushing down on the graph, which means that this border would keep going down and down and down and down forever. So because of that, I'm not going to put anything for my smallest range number. Coming up from the top, I can see that here is my biggest range number, my biggest y. It's where the graph touches, or it's where y is 5 on the y-axis. So that's going to be my biggest one. So I'm going to put that on the biggest side. And then I'm going to put my y in the middle. Again, because of the arrow, we didn't have a smallest value, so I don't have a smallest number here. And this would be my range now. Just y is less than 5. So any number that's smaller than 5, and you can see all the numbers are going down, 4, 3, 2, 1, 0, negatives. Any number that's smaller than 5 would be in the range. So remember,